The floor is warm. Not from sunlight, there are no windows here. Not from bodies packed into the room. The space is nearly empty. The warmth rises from below. Through 2 feet of solid stone, through mortar and brick and tile, heat is climbing. Silent, invisible, relentless, from a furnace you can't see, can't hear, and wouldn't know existed. This is the Roman Hypocaust, and in 108 AD, in a frozen military outpost called Eboracum, at the northern edge of the known world, a man named Numerius Calvus was about to build one from nothing. Eboracum sat where the river Ouse met the river Foss, a legionary fortress of the 9th Legion, surrounded by wooden palisades, watchtowers, and mile after mile of cold, gray Britannia. The winters here weren't like the ones Numerius knew. Back in Puteoli, along the coast of Campania, winter meant a cool breeze off the bay. Rain, maybe. A damp morning that burned off by midday. Here, the cold lived in the ground. It crept through stone walls. It sat in your bones and didn't leave until spring. The soldiers felt it worst. Legionaries who'd marched from sunlit provinces, Hispania, Africa, Syria, now stationed in a place where frost clung to iron and breath turned solid before it left your lips. Tribune Decimus Priscus had seen enough. His men were suffering, morale was cracking like ice on a water trough, and the solution to his military mind was simple.
We'll have warmth in this land yet. Keep the foundations level. Place the amber stones here. More timber for the framework. Secure the supports. Watch your step in the mud.
A proper Roman bathhouse in Britannia, with a fully functioning Hypocaust heating system, the kind that warmed the great thermae back in the heart of the empire. Priscus didn't care how it worked. He cared that it did work. That's where Numerius Calvus came in, a freedman from Puteoli, a calefactor, a heating specialist. He'd spent 20 years building hypocausts across Italia and the warmer provinces. He knew the mathematics of heat. He knew how hot air behaved under stone, how it rose through walls, how a single furnace could warm an entire building if you understood the physics. And he understood the physics.
A hypocaust is not complicated. Fire heats air. Hot air rises. You give it a path, under the floor, up the walls, out through the roof. Control the path, and you control the heat. That's all it is.
That confidence carried him across the channel, up through Londinium, and north along the Roman road to Eboracum. He arrived in late summer, with his wife Helvia managing 3 wagons of tools and materials behind him. The site Priscus had chosen sat just inside the fortress walls, a flat stretch of compacted earth near the barracks, close enough for the soldiers to reach, far enough from the granaries to be safe from fire. Numerius walked the ground on his first morning. He pressed his palm flat against the earth and held it there. Cold, deep, penetrating cold. Not surface chill, but something that reached up from below, as if the ground itself was stealing warmth from his hand. He'd never felt anything like it. In Puteoli, the volcanic soil was warm year-round. Here, the earth fought you. Still, he knew his craft. He sketched the layout that afternoon. 3 connected chambers. The frigidarium, the cold room, would need no heating. The tepidarium, the warm room, would receive moderate heat, and the caldarium, the hot room, would sit directly above the praefernium, the great furnace, where temperatures had to reach their peak. The design was standard. Pilae, short stacks of square bricks, would raise the floor 2 feet above the ground, creating a hollow space beneath. Hot air from the praefernium would flood this space, heating the floor above. Tubuli, hollow clay tiles, would line the walls, channeling rising heat upward and outward through vents in the roof.
I've built this system 30 times. The proportions are proven. The materials are known. We build it to standard. It works.
But that night, sitting in his quarters with a tallow lamp and a wax tablet, Numerius ran the calculations one more time. Heat loss through stone walls in Mediterranean climates, predictable, manageable. heat loss through the same walls. When the outside temperature dropped below freezing for months at a stretch, the numbers shifted, the margins collapsed. The comfortable buffer he'd always relied on in Italia simply wasn't there. The standard design would push heat into the subfloor space, yes, but in a Britannia winter, the cold ground and frozen air would pull that heat away faster than the furnace could replace it. The system that had warmed bathhouses across the sunlit provinces wouldn't be enough here, not even close. Numerius didn't tell Priscus about the numbers. Not yet. A calefactor who announces problems before he's found solutions doesn't stay employed long, not in the Roman military. Instead, he adjusted, slightly. He increased the prefernium opening by a third, ordered more charcoal stockpiled, and told himself the extra fuel would compensate for the extra cold. Then, he built. The first task was excavation. Legionary laborers, soldiers between campaigns, strong and disciplined, dug out the subfloor space across the entire bathhouse footprint. 2 feet deep, flat-bottomed, with drainage channels cut along the edges for any groundwater. In Britannia's wet soil, water was a constant enemy. A flooded hypocaust was a dead hypocaust. Next came the pilae. These were the spine of the system, short stacks of square-fired bricks, each stack roughly 20 inches tall, arranged in rows across the excavated floor. Every pila had to be level. Every gap between stacks had to be consistent. The hot air needed to flow evenly in all directions. If one section was cramped, the air would bypass it, creating cold spots above. Numerius supervised every row himself. He walked between the stacks with a plumb line and a straight edge, checking, correcting, adjusting.
Precision. Keep the line taut, not an inch off.
A young Britannic stonemason named Iovita watched from the edge of the site. She'd been apprenticed to the Roman construction crews, part of the local labor force that built and maintained the fortress. She cut stone, mixed mortar, hauled materials. But the hypocaust fascinated her. The idea that you could move heat through solid stone, direct it like water through channels, it felt almost like magic. Over the pilae went the suspensori, large, thick tiles that formed the actual floor of the bath. These rested on the brick stacks, creating a continuous raised surface. Mortar sealed the joints. A second layer of tiles went on top, then a thick bed of opus signinum, waterproof concrete made with crushed pottery. Finally, the mosaic surface that bathers would walk on. 4 layers of material between the hot air below and the feet above. Each layer served a purpose: structural support, waterproofing, heat distribution, decoration. The floor wasn't just a floor, it was a thermal engine. The walls came next. Tubuli, hollow rectangular clay tiles, were stacked against the inner wall surface, creating vertical channels from floor level to the roof. Hot air rising from the subfloor space entered these channels at the base and climbed upward, heating the walls from inside. At the top, flue vents released the cooled air and combustion gases to the outside. The entire building would become a thermal envelope, heat below, heat beside, warmth radiating from every surface a body could touch. Then came the prefernium itself. This was the heart. A vaulted stone furnace chamber, built into the hillside beneath the caldarium, with a wide iron grating to hold the fuel and a flue that channeled combustion gases directly into the subfloor void. The design had to balance draft. Too much airflow and the fuel burned too fast, wasting heat. Too little, and the flames choked. Quartus, a veteran legionary with scarred forearms and the patience of old stone, was assigned to operate it. He studied the furnace the way he'd once studied enemy formations, looking for weaknesses, testing responses.
You can't fight fire. You negotiate with it. Give it what it needs. It gives you what you need. Starve it, and it dies. Feed it too much, and it runs wild.
The first firing test came on a gray October morning. Quartus fed charcoal into the grating. The flames caught. Smoke poured through the subfloor channels. And Numerius waited, hand pressed flat against the caldarium floor above, counting heartbeats, waiting for warmth. It came. Slowly, faintly. The stone turned from cold to cool to lukewarm, and stopped. The tepidarium floor barely changed at all. The walls stayed cold. Priscus arrived within the hour.
Tribune Priscus. The embankment has collapsed. The aqueduct is severed.
Numerius knew what had happened. The Britannia ground was drinking the heat. The cold air outside was stealing it through the walls faster than the tubuli could replace it. His calculations, the ones he'd tried to compensate for with extra fuel, hadn't been enough. The standard design, the proportions he'd trusted for 20 years, weren't built for this climate. Iovita found him that evening, sitting alone beside the praefornium, staring at the furnace glow.
The clay you're using for the pilae joints, it's Roman clay, shipped from the south. It cracks in our frost. But there's clay from the riverbank, fire clay we call it. It holds heat longer. Our people have used it for bread ovens for generations.
The temperature must vary. Too hot and it fractures. Too cool it never
20
binds.
years of
Feel
certainty.
consistency.
And a Britannic apprentice was telling him his materials were wrong. Numerius's jaw tightened, his pride flared, but the cold floor beneath him didn't care about pride. He looked at Iovita, then at the furnace, then at his hands, calloused, soot-stained, the hands of a man who'd spent his life understanding heat. 3 days later, Numerius tore out the upper pilae joints and began rebuilding with Britannic fire clay. He raised the pilae height by 4 inches, increasing the air volume beneath the floor. He narrowed the tubuli gaps at the wall bases to force faster airflow into the vertical channels. He sealed every joint with double mortar, and he added a second praefornium vent to the tepidarium side, something no standard design called for. The second test was scheduled for the last day of October. Quartus loaded the praefornium at dawn. The flames roared. Hot air flooded into the subfloor void, hit the fire clay joints, spread through the raised pilae channels, and began, slowly, steadily, to rise. The caldarium floor warmed first. Not the faint, grudging warmth of the first test. This was real heat, climbing through the stone like something alive. Within an hour, Numerius couldn't hold his palm against the surface without pulling away. The mosaic tiles radiated a steady, even warmth that spread outward in every direction. The tepidarium followed, gentler, softer, the kind of warmth that seeps into muscle and bone. The walls, channeling rising air through the tubuli, began to sweat with condensation as the cold stone surrendered to the heat pushing through it from inside. Numerius pressed both hands flat against the caldarium wall. Warm, evenly, thoroughly, unmistakably warm. 20 years of building hypocausts, and he'd never felt a result like this. Not because the system was more sophisticated, but because it had been forced to adapt. The fire clay held heat longer. The raised pilae gave the air more room to circulate. The sealed joints stopped leakage that the standard design had always tolerated in warmer climates, but couldn't afford here. He'd built something the textbooks hadn't called for, something that worked not because it followed the blueprint, but because it rewrote the blueprint for this specific patch of ground, this specific cold, this specific set of conditions. Iovita was standing behind him. She didn't say anything, didn't need to. The warm wall said everything. The complete Hypocaust system, working at full capacity, was an engineering marvel hidden in plain sight. Here's how every piece fit together. The praefurnium, the furnace, burned charcoal or wood in a vaulted chamber below ground level. Combustion gases and superheated air flowed through a wide opening into the subfloor void beneath the caldarium. This void, supported by hundreds of pilae stacks, formed a continuous reservoir of hot air. That air didn't sit still. The thermal principle was elegant. Hot air naturally moves toward cooler areas. The praefurnium pushed the hottest air beneath the caldarium, closest to the furnace. As it released energy into the floor above, it cooled slightly and migrated sideways toward the tepidarium, delivering a second, gentler wave of heat. By the time it reached the far edges, it had given up most of its warmth, which is exactly why the frigidarium, the cold room, sat furthest from the furnace. Rising heat entered the tubuli channels at the base of the walls. These hollow clay tiles, stacked vertically, acted as chimneys, drawing warm air upward along every interior wall surface. The walls themselves became radiators. At the top, flue vents exhausted the now cooled air and combustion gases to the outside, creating a natural draft that kept the entire system flowing without mechanical assistance. No pumps, no bellows, no moving parts, just physics. The physics of hot air rising, cold air falling, and stone slowly releasing stored heat over hours.
By the gods, Priscus, can you feel that?
The bathhouse at Eboracum opened before Saturnalia, as Priscus demanded. Legionaries from the Ninth walked in expecting cold stone and military austerity. They stepped onto floors that warmed their frozen feet. They leaned against walls that pushed heat into their backs. They sat in the caldarium and sweated in a building surrounded by snow.
They don't know my name. They don't know I'm down here stoking this furnace 12 hours a day. They just feel warm. That's enough.
Quartus and two assistants maintained the praefurnium in shifts. The furnace consumed between 50 and 100 pounds of charcoal daily, a staggering amount that required a dedicated supply chain of woodland management, charcoal production, and transport. A single legionary bathhouse demanded more fuel than the fortress kitchens, but the expense was calculated, deliberate. Roman commanders understood that morale was infrastructure. Warm soldiers fought harder, deserted less, and endured longer. What Numerius built at Eboracum didn't stay at Eboracum. The adapted design, taller pilae, local fire clay, sealed joints, dual praefurnium vents, became a template for northern bathhouses across Britannia. At Aquae Sulis, at Viraconium, at Vindolanda along Hadrian's Wall. Engineers took his adjustments and refined them further. The standard evolved. The blueprint grew. And then, it stopped. When the legions left Britannia in 410 AD, the furnaces went cold, the praefurnia filled with rubble, floors collapsed into the voids below. Pilae stacks stood in darkness for 1,500 years, waiting. Archaeologists found them exactly where they'd been built. At Bath, intact pilae rows still support their suspensurae. At Wroxeter, the praefurnium chamber survives with soot marks on the ceiling from the last fire ever burned there. At Vindolanda, excavators uncovered tubuli still mortared into walls, hollow clay channels that hadn't carried heat since the 5th century, but could if someone lit the furnace again.
17th centuries. A testament to engineering.
The Korean ondol system, heated floors channeling warm air from a fireplace through subfloor stone passages, developed independently, but follows the identical thermal principle. Modern radiant floor heating, the kind installed in homes today, uses the same concept Numerius wrestled with in a frozen fortress 2,000 years ago. Hot medium below a floor surface. Conducted warmth rising through material layers. Even distribution through careful engineering. The technology changed. Water pipes replaced hot air. Thermostats replaced Quartus's careful hand. But the idea didn't change. Because the idea was never about Romans or Britons or any one civilization. It was about a simple human question, answered with engineering. How do you make a cold place warm? You raise the floor, you light a fire nobody sees, and you let the heat do what heat has always done: rise, spread, and make stone feel like something almost alive.
My grandmother heated her roundhouse with a pit fire and stone channels. She didn't call it a hypocaust, she called it common sense.
Numerius Calvus didn't invent the hypocaust. He didn't perfect it. What he did, what mattered, was carry it somewhere it had never been, and have the wisdom, finally, to let the land teach him what the textbooks couldn't. The floors at Hypocaust are cold now. They've been cold for 16 centuries, but the pilae still stand, the suspensorii still hold, and the principle, fire below, warmth above, comfort rising through solid stone, still heats the floors beneath your feet, in buildings all over the world that have never heard the word hypocaust. The best engineering is the kind you never notice, because it always works.